So I'm going to make a video on an example 5, but to begin, every time someone said hit or miss inside the Discord, all I could think of was this.
Hit or miss, I guess.
That's all I could think of. Anyway, let's begin. So how it works is, to save time, essentially for the first part of the question, for each of these references, identify the binary word address in tag and the index given and direct map cache with 16 one-word blocks. Also, list whether each reference is a hit or a miss, assuming the cache is initially empty. Okay, so here I have the cache. I'm assuming it's empty. Okay, and going forward, we're just going to take all of these, right? All of these addresses, they're in hex. Okay, you can go from hex to binary, right? And yeah, so knowing that, we can then assign the left 4 bits as the tag, and then the right, okay, so the left most significant bits is the tag, and the right least significant bits is the index. Okay, where that is from knowing that it's a direct map cache. Okay, so it's not the associative one. So since we know that, that's great. And then in addition, we know that it's going to be 16, and that's 2 to the power of 4. So therefore, this 4 tells us that we're going to have 4 bits for the tag and 4 bits for the index. Okay, great. Now, just quickly scrolling through the tags, we have the same repeating tags, and that's 0, 2, B, and F. Okay, which is great because then I can just simply write that as the tagged portion. Okay, now going through it, we just simply check the first tag and then the index. Well, the first tag is 0. It has nothing inside the cache already, so we're just going to fill it because it misses, because there's nothing there, so it's a miss. Next, we have the tag of B. B has nothing in it, so again, it's a miss, and we'll put that there, so it's 4. So this one is a miss, this one is a miss. Now we have tag 2. It's again empty, so we'll put it be the index there, so it's a miss again. Okay, here we have 0 again. Something's there, but it does not match the index of the previous one, so therefore we're going to erase it, and it's going to be a miss again. Okay, next we have B again, right? And we have something there, but it doesn't match the previous index, so we're going to erase it. We're going to put F there, and again it's a miss. Oh no, I guess I have to add an extra. I didn't notice the 5. That's okay, we just write 5 here and then F here. So we have the tag bit tag 5. Tag 5 is empty because we have nothing there, so we're just going to write 8 there, which is the index of the current one, to replace the old one, which was nothing, and it was missed. Now we go B again, and E does not match with F, so again it's a miss. We replace it and we write it as miss. Now we have 0 again. E does not match 2, so we're going to replace the 2, which is the previous one, with E, the current one, and we're going to write miss. Now we have B again. B, current index is 5, which does not match the previous index of E, so therefore we're going to erase it and write 5. Miss. Now we have the tag 2. Tag 2 is, it has something there, but it's not C, it's B, so we're going to erase the previous one, right over it, and it's a miss again. Okay. Okay, now A. What happens for the tag bit B? Again, it doesn't match, so we're going to erase the previous one, and the index is A, so we're going to write that there. And we'll simply just write it as a miss again. And finally, F. Nothing was there, so it's again a miss, and we'll just write it there. So if it was to continue to iterate, we would go for the second iteration from this cache. That might be something important to understand, is that this was the first iteration through. Okay. So this was the first iteration. But if we were to have a second, it would continue from this current cache state, okay? That's important to understand. Okay, going on to the second part, there's something that needs to be explained beforehand before continuing to get to the answer, and that's for everyone's understanding. And I also am pretty confident that this is where everyone's confusion is spawning from. So first, in our memory hierarchy, we have the cache, which happens before the main memory. Okay, so that's important to understand. And so since it's direct mapped, then it goes like, if we recall that I drew a cache something like this, right? Like this and like this, okay? And then it has maybe some more rows like that. These directly map to the main memory like that, okay? So in order to understand that, we have to understand how the main memory would be set up, in our case for 16 one-word blocks. Okay, so 16 one-word blocks, right? So 16 one-word blocks. No, that's for the first part. For the second part, for each of these references, identify the binary word address, the tag, and index, and the offset given a direct match with 2 word blocks. Okay, so 2 word blocks. Here we go. So yeah, now I understand it. Okay, so 2 word blocks. So we have the main memory. Main mem. That's mem. Okay, and it's gonna be something like this. Okay, so this is the memory, and it is, there we go. This tag is for the cache, and since it's directly mapped, these remaining 4 bits at the end are what is the same here as it goes to the main memory. Okay, so we're gonna have 0 0 0 0 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1 0 1 1 0 0 1 no yeah 1 1 1 0 0 0 1 0 0 1 1 0 0 1 0, and I can simply move this up here like that, and then it's going to be 1 0 1 1 1 1 0 0 1 1 0 1 1 1 0 1 1 1 1 0 1 1 1 1, and so it takes 4 bits to represent 16, right? Because this is going to be 8, 4, 2, and 1. So 8 and 4 is 12. 12 plus 2 is 14. And this last one is 15, right? So 0 to 15 is 16 in the case of computers. So that is that. Because the number from here to here is 16 times. Like this is the 0th and this is the 15th, right? So that's how we know that there's 16. Next, it says there's 2 words per block. So in the first, if it was for the first one, each of these has its own index, right? So like this is why, if it was one block, each of these would have its own index, okay? And it would go all the way down. But because it's 2 word, there's going to be 2 of them per block, okay? So since there's 2 per block, like such, yeah, so we're gonna have block 1, block 2, block 3, block 4, block 5, block 6, block 7, and block 8. Now, we can start to dissect some patterns here. So the first pattern is, so we said that this is our index, the 4 least significant bits of our binary address. Okay, so that's great. What else can we notice? Well, we can notice the least significant bit, the very least, this one right here, it oscillates. It's either a 0 or a 1, 0 or 1, 0 or 1, 0 or 1. And this correlates to our offset. Why? Because, well, you'll have 1 here and 1 here. Like you'll have some data here, so we'll call it word 1 and word 2, right? And you're going to use that offset bit to either choose the first word or the second word, or in this case, ooh, no. So it's either going to choose 0 or 1 with the offset bit. So that's what the offset is for, right? And what's the index for? Well, the index is going to be the 3 most significant bits of our index. And our index is this, right? So these 3 bits is what's going to be our index, because they are the same for the first 2. So example, both 0, 0 belong to block 1, and they both share 0, 0. One has an offset of 1 and the other has an offset of 0. So that is essentially what's happening, right? So this index is going to belong to 0, 0. This one's going to belong to 0, 0, 1. I'm just going to write it in decimal because it's easier in my opinion. And this one's going to be 2. This one's going to be 3. This one's going to be 4, 5, 6, and 7. Okay? So that's exactly what is happening inside our memory at this moment in time. So I'm just going to erase this now. Take a moment. I'm going to have a glass of water. You can have a moment to understand this. Okay, so I'm going to erase this now, and we're going to simply fill out our tag and our offset. So what's our tag going to be? I'll keep it in binary for a simple. So it's going to be binary all throughout. So our tag's going to be base 2, our index is going to be base 2, and our offset is also going to be base 2. Okay, And I'm going to write these columns to make some organizations. I'm not going to put the rows because that's a little bit difficult for me. So we're going to put 1, 0, 1, 1. This is going to be 0, 0, 1, 0. And this is going to be 0, 0, 0, 0. Did anyone else notice that color fade, or was that just me? So let me just move these up so I can easily understand where they're going to. It's going to be 1, 0, 1, 1, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 0, 0, 0, 0, 1, nope, 1, 0, 1, 1, 0, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 1, 1, 1. Okay, great. Now for our index, we're going to have 0, 0, 1. Why? Because it's these 3 bits right here. And then our offset is going to be 1. Okay. Next, we're going to have 0, 1, 0, and our offset is 0. And then we will have 1, 0, 1 with an offset of 1. Okay. And then it's going to be 0, 0, 1 with a offset of 0. Now we're going to have 1, 1, 1. Oh, I have to rewrite it. No, I don't have to rewrite it. I'll just move it again. So this goes up here. This one correlates with that one. This one goes with that one. This one goes with this one. And this one goes with this one. And this one's going to 1. This one's going to be 0, 1, 0, 1. Then we got 1, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 0, 1, 1, 0, 1. All right, great. Now we can get started with the cache. So to get started with the cache, we're just going to simply take this, resize it, make it, I'm going to enlarge it, move it over here. Okay, I'll leave it like that. Rewrite this so it's to scale. And yeah, so we're going to have our tag. And we're going to have our index. Now, why am I only writing tag and index? Well, because to the cache, that's what's important. And the offset, right, that I spelled wrong, offset, the offset is for choosing one of the 2 words inside that index, okay? So the cache essentially, it really only cares about the tag and the index. And for that reason, okay, so let's continue from where we were. We're gonna now write the hit or miss, okay? And so in order to do this, we have to understand the tag and that there's 2 index slots. The reason why there's 2 index slots is because each block inside the real memory has 2 words. And because of that, we have to allow ourselves the opportunity to go to maintain the index for twice. For like, we have to keep 2 indexes there, essentially, is what I'm trying to say. All right, let's begin. 0, 0 is empty, so we can write 0, 0, 1. Okay. And it's a miss. Next we have 1, 0, 1, 1, which again is empty. Actually, I should write it here because its offset was 1. So it's going to be 0, 0, 1, right? And me writing it here or here does not matter. I just did that because I wanted to, and the offset was 1. So anyway, going forward, we have 1 0 1 1 as the tag. It's empty, and so we're just going to write this 1 0 1, and it's a miss. No, sorry, I said that wrong. It's 0 1 0. Now we have 0 0 1 0 as the tag, and the index is empty, so I'm going to write the index there, which is 1 0 1, and it's a miss. Now we have this again. Okay, it's 0 0 0 0 as the tag, and we have the index there, so that's great. So in fact, it is a hit. Now we have 1 0 1 1 again, but the index does not match, so we're just going to write it in the other side and write that as miss. Now we have 0 1 0 1, which is here, and it's empty, so we're going to go ahead and write 1 0 0, and that's also a miss. Now we have 1 0 1 1 again with the same index, so this is the same as this, and this is the same as this. So it is in fact going to be a hit. Now we have 0 0 0, zero zero zero, which is this, and it doesn't have the same index, which is 1 1 1, so we're just going to go ahead and write that in, and we'll write that as a miss. After that, we have 1 0 1 1, which is this one, and one of the two indexes match, so in fact it is a hit. Okay, and then we have 0 0 1 0, which is this one, and it does not have the same index, so we'll just write it in 1 1 0. Okay, and now we go back to 1 0 1 1, which is this one, and in fact we already got this one, so this is what, so we used this one like the longest time ago, so because of that we're going to erase it. All right, and then when we erase it, we're going to write in the recent one, which is this one. Okay, now we're going to move on to the next one, which is 1 1 1 1 1 1 1 1, which would be the 15th or the 16th, however you want to. If you're going from 0 to 15, then this is the last one. If you're going from 1 to 16, then it's still the last one. Okay, and because of that, we never used it before, it's empty, so it's just going to be 1 1 1 0. So I forgot to say these are all misses. But essentially, that is the understanding of what's happening. I hope everyone understands, and it was helpful. I'm sorry if my confidence simmered out to the end, because in my first take of this, I didn't write it with 2 indexes, and so I wasn't able to get this one correctly. So I had to go back and remake it, which was a little heartbreaking. But anyway, this definitely the first part and the explanation of the cache to the memory was extremely helpful. I know that for a fact because that was the tipping point for my understanding here. Anyway,